There are lakes in space. This isn't a pedantic point about how the Earth is in space, so Earth's lakes are technically also in space. These are lakes in places other than Earth. Now, the Earth is the only place that we know currently has lakes of liquid water on its surface. But if you relax any one of those conditions, current, liquid, water, or surface, there are loads of lakes all over the solar system, and probably beyond. Let's explore. Let's jump right in with some extremely cool lakes. Hundreds of degrees below zero, in fact. These lakes can be found on Saturn's largest moon, Titan, and they're current liquid surface lakes, but not made of water. Instead, they're made of liquid methane and ethane, hydrocarbons found in natural gas on Earth. The three largest are named mare and are named after sea monsters, while the rest are called lacus and named for lakes on Earth. The largest mare, Kraken Mare, is a bit larger in area than the Caspian Sea, Earth's largest lake. One study of radar data from the Cassini space probe suggests that Kraken Mare is at least 300 feet deep and potentially over 1,000 feet deep, and that it's composed of about 70% methane, 16% dissolved nitrogen, and 14% ethane. 97% of Titan's known lakes are in the area around its north pole, including the three mare, Kraken Mare, Ligeia Mare, and Punga Mare, and the largest lacus, Jingpo Lacus. The second largest lacus, Ontario Lacus, is near the south pole. Titan's methane cycle is the closest known analog of Earth's water cycle anywhere else in the solar system, featuring lakes, rivers, islands, rain clouds, and potentially even rainbows, though they'd probably only be visible in infrared light. Titan is the solar system's only moon with a thick atmosphere, making it the most obvious moon for lakes, but it's actually not alone. A completely different sort of surface lake shows up on another outer solar system moon, Jupiter's moon Io. Io's Lustig-Yaeger is a 126-mile-wide lava lake, the largest of several lava lakes across Io. For comparison, the largest lava lake on Earth is less than 1 mile across, located at Mount Nyiragongo in the Democratic Republic of the Congo. Io's lava lakes were first imaged by Voyager 1 and 2, and have since been studied up close by the Galileo, New Horizons, and Juno spacecraft. The lakes are mostly molten silicate rocks, with a thin layer of solid rocks floating on the surface. These rocks periodically sink and are replaced with fresh lava, in a similar manner to Earth's lava lakes, or to a lava lamp. On Lustig-Yaeger specifically, this cycle of resurfacing moves in waves that cross the surface over the course of several months. Io's lava flows are heated by tidal flexing, where the gravity of Jupiter and Io's neighboring large moons squish Io's interior, warming it through friction and making Io the most volcanically active body in the solar system. Liquid hydrocarbon and lava lakes are definitely exciting, but not really useful for, say, drinking from. What about water lakes? Planetary scientists think there's actually quite a lot of liquid water in the solar system, but most of it is underground. The most famous predicted global underground ocean is on Jupiter's icy moon Europa, which, like Io, is warmed by tidal heating, and which may have twice as much liquid water as Earth does. Many other icy worlds are suspected to have global underground oceans too, including Jupiter's other moons Ganymede and Callisto, Saturn's moons Titan and Enceladus, Neptune's moon Triton, and several icy dwarf planets including Pluto. Enceladus, the smallest of these bodies, has a surface area more than twice that of the Caspian Sea, so these would all be more like oceans than lakes, at least in terms of area. But we don't have to give up on these worlds having lakes just yet. Many icy worlds are known to be cryovolcanic, meaning they erupt ice in plumes and geysers into space. It's entirely possible that these worlds could form cryolava lakes, lakes of icy water kept at least partly liquid by geologic heat. Indeed, Voyager 2's pictures of Triton show some frozen former cryolava lakes. A cryolava lake could qualify as a current surface water lake in the solar system beyond the Earth, if we can actually find one, that is. And underground water doesn't have to cover an entire world. Ceres, the largest object in the asteroid belt, is thought to have saltwater brines flowing in pockets below its surface. In 2018, scientists at the Italian Space Agency presented evidence for another subsurface lake near the south pole of Mars. The Mars Express spacecraft spotted a particularly bright radar reflection that's consistent with salty water. The lake would be about 10 miles across and below 1 mile of ice. Since the announcement, planetary scientists have proposed other possible explanations for the radar reflection, including very salty ice or particular minerals, so we'll need more data to confirm whether the lake is actually there. But even if Mars doesn't have a current underground liquid water lake, it has no shortage of now dry former lakes on its surface. Mars billions of years ago was probably a watery world like Earth is today, though exactly how watery is still under investigation. Several impact craters have geologic features like deltas and sediment layers that are best explained by former lakes. This list includes both Gale Crater, landing site of the Curiosity rover, and Jezero Crater, landing site of the Perseverance rover and Ingenuity helicopter. Valles Marineris, Mars's gigantic rift valley, may have also held water in the past. Mars is also home to quite a lot of permanent water ice. A lot of it is in the two main polar ice caps, which are both made of water ice and frozen carbon dioxide. But there are lake-sized ice features as well. Korolev Crater in the northern hemisphere is filled with a 37-mile-wide sheet of water ice. The crater acts as a cold trap, enabling it to retain its ice even in the summer when ice sublimates away from the terrain nearby. Other craters, like Louth Crater, have similar features. Beyond Mars, we also think there are ice deposits in permanently shadowed craters near the poles of the Moon and Mercury. There are a few honorable mention sort of lakes worth noting here too. Pluto's Sputnik Planitia has flowing nitrogen ice sheets and glaciers, but they're not liquid so much as a squishy solid. The Moon has features designated as Mare and Oceanus, Latin for sea and ocean. While early astronomers thought they were actually bodies of water, modern research has shown them to be solidified lava flows. So these solar system lakes are all pretty neat features to learn about, but none of them are quite the same as Earth's lakes. If we want to find a true body of water in space, we may have to look beyond our solar system. There's certainly no shortage of exoplanets to examine, given that we already know about many thousands of them. But they're so far away that we basically have no chance of seeing surface features on even the nearest ones with any telescope we could hope to build in the near future. Some speculative designs could pull it off, like flying a telescope 20 times farther out than Pluto to use the sun as a gravitational lens, but there might be an easier way. As an Earth-like planet rotates, its brightness changes as sunlight reflects off more ocean or more land. An observer in the right position would also see a burst of sunlight glinting off the ocean's reflective surface, an effect which we've seen with Titan's lakes as well. Measuring these two effects could allow a telescope to detect oceans on a nearby exoplanet. A 2018 paper suggested that a properly equipped space telescope, the size of the 6.5 meter wide JWST, could detect potential oceans on a few nearby known habitable zone planets. JWST itself can only image exoplanets much larger and farther away from their host stars than Earth. But NASA has plans for a future telescope of the same size, the Habitable Worlds Observatory, that should be able to pull it off. So with Mars's dried-up desert deltas, Io's liquid lava lake Loki, Titan's many methane maria, and sundry subsurface seas with curious cryovolcanic craters, our solar system has no lack of lakes to list. While some are more similar to Earth's lakes than others, all of them showcase the variety of geologic factors that form the universe we see today, and that's pretty great. Be sure to leave your feedback in the comments and subscribe if you want to see more like this. And as always, thanks for watching.